I work with NetSquare, Chase Bank, IBM, and Foundstone. My interest is web security research. I publish several papers and articles which you can find on Security Focus, O'Reilly, DevX, Inform IT, etc. I release some of the tools: WS Scanner, WS Chess, MSN Pawn, AJAX Finger, etc. I published several advisories on .NET and Java application servers. These are some of the books which I wrote: Hacking Web Services and Web Hacking. I'm working on a book called Web 2.0 Security, which due in December. First, before we start, we'll just quickly look at the Web 2.0 industry trends and technologies. These are some of the 2.0 new application. The old applications have been converted into this new application, and Web 2.0 has three layers or three distinct technologies which are associated with AJAX, rich internet applications running with Flash, and a web services where Open API or web services based API is running. By the end of 2000, Gartner is predicting 50% of languages, 30% large companies would have some kind of a Web 2.0 component into their applications. So you can see in last 2 years, if we say 2005 onwards, we are seeing adaptation of 2.0 applications, then this is the way it is going forward. Web services is forming a backend and access on XML protocols. AJAX is empowering browsers. Now, browser is sitting with AJAX components, so it is pretty easy to use them. Rich internet applications are consuming backend web services. Now, what we're seeing is like a Flash-based application get loaded in your browser as a plugin, and it will access backend web services, backend open APIs, and such. Search engines are helping in building up mashups and various different applications, and now they have published their APIs through which you can access Yahoo, Google, MSN, etc. 2007 web services would rocket from 1.6 billion to 2000 to 34 billion dollars. It's a prediction by IDC. Web services oriented architecture, or broadly now known as SOA, service oriented architecture, would surge ahead. That's the Gartner's prediction. Web 2.0 is not just now locked into a social sites and such. It is penetrating deeper into enterprise 2.0 applications, where large enterprises like IBM, Microsoft, etc. are integrating certain applications on this particular platform. So there is a large application base which is on the change, which is converting from 1.0 to 2.0. Here is a very simple architecture of a Web 2.0 application would look like. You have your browser where AJAX, RIA, HTML, JavaScript, and DOM is running, and then you connect to internet and you access your so-called start page, for example, the Web 2.0 start page like PageFlex, Google homepage, Google/IG, or NetVibes, or etc. Now, in this particular start page, over internet, various different things are integrated. So you can, on that particular page, you can read your mails. On that page, you can read news. On that particular page, you can read documents. You can read weather. If your bank or trading portals have already provided APIs, then you can integrate those APIs in that particular page. You can select various RSS feeds and read them as well. This 2.0 start page would have its own database, and it would have its own authentication page. And now on top of it, this particular start page has been converted into another web services. So your Web 2.0 start page can be consumed by a completely different application, or another Web 2.0 application can integrate this particular page into their application. So you can see large application to application level interaction is going on, or you can say like internet itself is emerging as an application framework, where one application can consume 12 applications, and then that particular application can be integrated into another 12 application, and so forth. So that's where the complete 2.0 architecture is emerging. If you look at the Web 2.0 components, I would like to divide these components into 4 categories. One is a client layer, where we are seeing AJAX, Flash, HTML, CSS, JavaScript, widgets, popularly known as widgets or gadgets or modules or such, which sits small JavaScript components which sits into your browser, which covers some of the area where it is running and then communicating to the backend applications. And DOM, that's the document object model. Now, if you look at the protocol layer, where a lot of changes has come, we used to have HTTP and HTTPS. Now we have a SOAP, XML, RPC, and REST running on top of HTTP and HTTPS. So there are 3 or 4 new components or new protocols which are coming into picture. That will talk with the backend structures. Now, in the past, if you have seen, Web 1.0 application would be talking from client to server. In client would be sending a post or a get request where a query string or a post buffer would be there, but now client is empowered by sending a JSON stream, XML stream, RSS atoms, text, JS object, customized objects, etc. And similarly, server can send various feeds back to the client, which is JSON, XML, RSS, etc. So there are completely new layer or a new streams which can talk from client to server or server to client. And if you look at on server layer, you have a SOA, that's a service-oriented architecture or web-oriented architecture. You have a SaaS, that is called software itself as services, web services, AJAX, traditional APIs, etc. would sit into that server layer. And if you look at the technology, now you're on internet, you will have web services client or a web client, you have a firewall, you have a DMZ where web servers or scripted web engine would be sitting. Then it will be talking with the application server and integrated framework, or it will be talking with ASP.NET, with .NET J2E application server, and you have a web services DLL or a web services plugin into your layer, which is talking on SOAP, REST, or XML RPC. So this would look like a picture of a typical application. Looking at the 2.0 security, complex architecture and confusion with technologies. We have seen a Web 2.0 worms like SAMI, Yammer, Space Flash, etc. This is essentially leveraging client-side technologies and propagating itself using cross-site scripting and cross-site request forgery. AJAX and JavaScript, client-side attacks on the rise. We are seeing a lot of different ways of exploiting JavaScript running in a browser. Web services attacks and exploitation is going on. We have a Flash clients. It's also running at a risk. Now you can download the Flash client, decompile, and reverse engineer the logic. Watch out Web 2.0 security risk. That's what Gartner is saying. Mashups and untrusted sources. Now application is mashing up left, right, and center. So for example, you are looking at one application which is suggesting that we are a mashup from a Google. Now they have a control of whatever information coming from a Google before they post on your browser. So for example, if that mashup application is from untrusted sources, then it is possible that information is manipulated. So you are assuming that this information is coming from Google, but it is manipulated in between. RSS feeds manipulation and integration. A lot of RSS readers are coming up which are sitting in a browser. Now if these RSS readers are insecure, then it is possible to inject certain content into RSS feed, which will either do a cross-site scripting or cross-site request forgery or any other remote JavaScript execution on the box. Now you are taking this RSS feed from various untrusted sources. Like wherever you see like this site looks good, let me take its RSS feed. So you take RSS feed and integrate it into your application, but there is no security measures is there since the data is completely untrusted. Widgets and third-party components. We are seeing a lot of widgets and third-party components coming into application and sitting, which is never code reviewed or such. So what we are seeing over here is there are various different old attacks which are now coming into picture, which are attacking the application layer through a new carriers. These carriers can be SOAP-based envelope. This carrier can be REST-based protocol and such. We are seeing 4 vector of changes in an application layer. And each of these vector has its own impact. One is application infrastructure, second is the security threats, methodology, and countermeasures. If you look at the application infrastructure, you have a changing dimension, protocols, Web 1.0 running with HTTP and HTTPS, Web 2.0 is running with SOAP, XML, RPC, REST, HTTP over HTTPS. Information structures, we used to have HTML to deal with, now we have XML, JSON, JS object, etc. to deal with. Communication methods, we used to have a synchronous post-back refresh and redirect method for 1.0 application. Now we have asynchronous and cross-domain proxy to deal with for Web 2.0. Information sharing, single place of sources from which we used to share the application, which is a local database. Now we have multiple sources because we need to integrate a lot of different sources into one application. So pretty much Web 2.0 is running with the multiple sources, the multiple applications. Now, if you look at the security threats, entry points, Web 1.0 application entry points were structured. We used to have login page and then customer page and then this page and this page and logout. So you know like how you can traverse into application. For Web 2.0, it is like AJAX page making backend requests. So there are scattered entry points to the application. There is no one path on which application has to work. If you look at the dependencies, Web 1.0 used to depend on limited sources. Now it has multiple technology, information sources, and various protocols. If you look at the vulnerability, Web 1.0 has full focus of vulnerability on server side. Now Web 2.0 has to deal with the web services as well as the client side, XSS and XSRF. Exploitation, we used to have a server side exploitation only. Now we can say beef or many other proxies which can help in doing XSS based exploitation on a client. If you look at the methodology side, then a footprinting, we used to do typical footprinting using hosts, but now you can do a lot of different footprinting to a Web 2.0 application from a search engine. Discovery used to be very simple in Web 1.0 application, but for a Web 2.0 it is very difficult because all calls are hidden. They are in part of the JavaScript, so it's very difficult to do discovery. Enumeration, you used to have a structured enumeration. Now we have difficult enumeration because several different streams are coming into picture. Scanning, it was a structured and simple. Now scanning is very difficult because you have a extensive AJAX usage or a RIA based component usage. Automated attacks, it was easy after discovery. Once discovery is done, it is very easy to do attacks. But for 2.0, you have various different streams to deal with. So you have to first JSON, you have to first JS object, etc. So it's making very difficult to do a automated attack. Reverse engineering, usually the code was residing on a server side, but now on 2.0, the code is residing on a client side and a server side. So pretty much either you can download a Flash object and try to decompile and see what is running with, or you have a large JavaScript files coming to you which you can run through and try to dissect the code. Code review focus on server side only. Now we have a client side analysis as well. Countermeasures, owner of information, now used to be on a single place. Now it's a multiple place. Browser security, simple DOM usage. Now DOM usage is very complex. Validation, we used to have a server side validation only. Now if a stream is coming through RSS and untrusted sources, there should be some validation going content to the DOM. Logic shift only on a server side. Now we have a client side shift as well. Secure coding, we have a structured and single place, now multiple place and scattered. So this is a overall change of Web 2.0, how industry has been changed, how new vectors are coming into picture and impact on each of these four categories. Now we'll look at AJAX. We'll look at attacks, threats and countermeasures for AJAX. Very simple basic AJAX, you have HTML, CSS, JS DOM, and now you have an XHR object, XML HTTP request object. This is a key object for AJAX. This makes, XHR object makes entire technology asynchronous. So now you have like a raw socket or you can say a socket which you can open to backend applications. So you have an XHR object which can make asynchronous over HTTPS, which will talk with the web server. Web server will talk with XML, middleware text, and that will talk with the database server, and the entire stream will go back. Here is a very simple line of code where you can load the HTML dynamically. Top end, we are defining XML to XML HTTP object, so we get a handler to the HTTP object. Then we open a connection with, say, we want to open a get method, call for a main.html. True means asynchronous call, we are making it true. And we wait for a call to finish. So we will wait in an on ready state. Once we get a main.html page coming to us, we'll take the page and change the DOM context. So this is a very simple way. So essentially the core difference between 2.0 and a 1.0 is, for a 1.0 you have to refresh and reload the entire page. For 2.0 you don't have to refresh the page. You make a request, and then once response comes, a small text or a small DOM component will get changed. So a 2.0 application, you can see like a multi-threaded application running on your single instance of a browser. So it is making multiple requests from a backend, and you don't have to wait for a response to come. First, we'll see AJAX fingerprinting. How you can do a fingerprinting, which AJAX technology the target is running with. So determining AJAX calls, we can fingerprint the framework There are various different AJAX technologies out there like Atlas, GWT, MochiKit. There are almost 10 to 15 libraries out there, and they have their own security issues or holes. AJAX fingerprinting is a very simple tool which I have written by which you can do the assessment. I'll just quickly show you. Over here. So for example, I have this is a demo site where you have AJAX calls. Here is a very simple AJAX call I want to make. There is a plugin called Firebug. If you open a Firebug plugin, and it has a console in which you can see the typical XHR call going on. So I click on a get AJAX. As you can see, I got this got it text. Just that particular DOM string has been changed, and this is a get request has been made at the back end. Similarly, I go for a AJAX proto. Similarly, I get this. Now, if you look at the view page source, what I'm doing over here, I'm using prototype.js. That's the library which I am using, and here is my simple code which I already shown. And here is another piece of code which is specific for a prototype library. So now I can, for example, on this particular page, I want to run my tool for fingerprinting. So this is a very simple Ruby script where I run and try to figure out what it is running with. I just paste the URL. So on this particular URL, I want to see which kit AJAX is running with. So here it has scanned the entire page. It has found that there is a file. All include files it has identified. It is running with prototype.js. So I have mapped over here that this particular file or this particular component or this particular page is running with prototype.js found. Similarly, there are various different signatures which I have covered. You can find Dojo, you can find DWR, Moo.fx, Rico, Yahoo UI, GWT, Atlas, jQuery, etc. So this is the way you can do a fingerprinting. You can find this these tools I'm going to post on site, so you can find these tools. Talking about some of the structures, there are various different structures. Like I'm making this structure request, which is a JSON stream. So I'm getting back a JSON stream. As you can see, JSON stands for JavaScript Object Notation. So I'm getting as my response stream, I'm getting a JSON, and that is painting the entire DOM once again. Similarly, you can call for XML. If you call, then the XML stream will come and paint the browser. Similarly, there are JS objects, scripts, JS array, etc. you can call. So there are various different streams coming to a browser and going out from a browser. Okay, going back to the presentation. So AJAX enumeration, identifying XHR call, decoding the backend calls, information enumeration. You can use these Firebug tools and try to identify whether it is using JSON, XML, JS objects, etc. You can tools to determine which technology it is using. It gives you valuable information. One of the major problem with AJAX application is that you can't crawl the application. How do you crawl the application? The entire calls which are going back and forth are automated calls. So you can't crawl the application as such. The traditional crawlers are actually failing because every call is hidden and every call is dynamically. So once page comes into browser, it gets loaded into a browser. From a DOM, you can trigger the events. So it is like a crawling is more like an event based rather than just crawling the hrefs. So this is one of the challenges which we are seeing to do crawling. So over here, for example, I have a page which is, say, crawl. Now look at this page. This is a very simple page where a login, news, your area or profile, a bar on the top. Now if you look at the view source, there are no links. There are just the JavaScripts which is coming to you, and these JavaScripts a function called load HTML, which is loading the main area and a my area. So if you start crawling in this particular page, the crawler will stop. There are no hrefs. There are no links. But on a page, on a DOM, you can see these links because it is a dynamically created links. Now if I click news, the page source would be same because everything is dynamical now. So for a crawler, there is just a one page, but in this particular page, you have various links like your area, profile, everything. This, for example, coming, this link, this area is coming from a JSON or such. So how would you crawl these applications? This is a bigger challenge which we are seeing, because anyway you have to do some automated crawling to fetch these links. There are different approach to it. One of the approach which I am taking for crawling these application is running application with a tool. There are ways you can remotely control the browser events. For example, for a Firefox or IE, you can remotely control the browser. So what I'm doing over here is I'm using a toolkit called Watir, which is a Ruby-based toolkit or a Ruby-based tool which can give you handler to IE. So then from a IE, from a script, I can control the entire IE. So for simplicity, I will just run this in an interactive RB mode, and you can script it all together and we can run as well. So I say IRB. Now I say require. So I'm just calling Watir. So it is loaded. Now I just include it. Oops. So now the object is loaded. Now what I'm saying is my new IE is equal to IE.new. So new browser of IE has been created. Now I can control this particular browser through my script over here. Now I would say IE go to this particular page which I want to crawl. So I will go to this particular page. That page is loaded in my IE instance. Now pretty much I have a complete access to the DOM, which the traditional crawler would not have. So now I can say IE dot show links. So these are the 4 links which are found in a DOM. Your login, which is pointing to login.asp. Now you can interestingly see the news, your area and a profile, which is pointing to a JavaScript. So now if you even parse this page, you are going to get a JavaScript. You have to actually initiate, or you have to click the event for the right page to get loaded in your DOM. So now from this, what I can do is I can even control the links. So I say IE links. I want to say click link number 2. So I say 2 and I say click. So now this is clicked. You can see the page has been changed. Now I say links. So I get I get few more links. Now over here I click on say link number 3. So 3 is clicked, and now I run IE show links. So now I have 7 links. So this is the way once you load the page and get access to the DOM, then you can start harvesting various different links. So this is the way you can do a crawling. So this is the only possible way how you can do AJAX based crawling. This is the way you can crawl the AJAX application. If you have a say AJAX based application, you try to run various different products, you try to run various different crawlers, and you will see it will not find the links. It will not find those dynamically created links via JavaScript. So this is one of the challenges which we are facing, and this is the way we can address this challenge. So automated crawling with a browser is required. This is a new approach which is required. Now second is AJAX-based attack points. How to find AJAX-based attack points or AJAX-based entry points. AJAX components and widgets get loaded in your browser. Cross-domain vulnerable browsers and callback implementations are there. DOM manipulations is possible. insecure eval calls, which is pretty much insecure eval calls can cause a cross-site scripting. Malicious HTML tags can be injected now. Intranet nodes and internal resources can be scanned once malicious code get loaded in your browser. So there are various different issues which we are facing. Some of the attack vector is one needs to scan for entry points in AJAX. For a cross-site scripting, cross-site request forgery, client-side code reverse engineering is required, security controls and validation bypassing is possible in a code. So various different issues are related with this. Now, how to scan AJAX-based code? For example, if we go to demo, over here what I have is, say, some of the XSS vectors. Now, over here, I have a take this. This code, what it is doing is actually, it is calling a profile. Say for example, you are on a.com and you want to see someone's profile on blog.com. Now, this blog.com has provided an API by which you can access the blog.com. So what your developers have done is, from a browser, it will make a request to the target. Now, XHR request cannot be make cross-domain. So it is like following a single origin policy. So it will make a request back to the browser to the server. Server will be running the proxy code. So it will ask blog.com to send a profile information, and that profile information will shown on your browser. Now, this blog.com's information is not validated. Like, you don't know what someone has posted on its blog, what is posted in your profile or such, and it is sending the XML stream back to the server. And these XML stream has been converted into HTTP response object, and you can see it is loaded with a profile, and then you are writing the DOM in this particular case. Or you go back and say we use this view page source. Over here, as you can see, what it is doing is it is making a eval call. So whatever response stream which we get from an untrusted source, we eval it. Now all these points, document.write, eval, and there are various other points which can cause a third generation cross-site scripting. We have a persistent, we have a non-persistent XSS. Now we have a third generation XSS which is called DOM-based XSS. These are the DOM-based XSS which you are looking at. So now, as soon as I click here, you can see the XSS has successfully executed, because the stream which is coming from a third-party source which I am evaluating is manipulated. Someone has posted on its blog a malicious JavaScript which is coming through this proxy to my code, my box, and my box getting compromised. So this is the way we are seeing some next generation cross-site scripting, which is possible with JSON stream, which is possible with XML stream, which is possible with scripts, which is possible with JS array, or it is possible with the JS object. So this is becoming a bit scary scenario. If you open say, for example, if you are scanning, if you open a NetVibes or a PageFlex or a Google page and try to see what kind of a streams coming to your browser, you will see JSON, you will see XML streams, RSS. So now you are seeing various different components coming into your browser. So how do you scan AJAX code? How do you scan the AJAX code for these kind of entry points? Scanning AJAX component, retrieve the JS include files, because where the vulnerabilities are. Identify XHR calls. You want to see where the XHR call is. When you have XHR call, once XHR call is made, new content has been loaded in your browser. So whatever operation happens after XHR call would be very interesting, rather than looking at the entire JavaScript. Once you have the XHR call, grab the function which is making the XHR call, so you know like from which function is calling this XHR. So you can reverse track and try to identify from where this particular call is coming. A mapping function to a DOM events, and scanning code for XSS. Look for eval, look for document.write and such. So for example, here is a message or a JS object which is coming to me, which is from to subject, body and such, and now you have a document.write with these objects. Now, if the subject has been manipulated with a script, then these particular stream will come to browser and cause an XSS. So you are looking for these kind of calls. Over here we have a JSON issue where you have a JSON stream where interesting link is coming. So someone is sending the href in a JSON. Now, if this href has a JavaScript colon something, then what is going to happen? As soon as you click the link, JavaScript get executed in your browser. Or here is a JS object where new array is coming, where you have a name, etc., and then you have a comment. Now, if a comment has a embedded JavaScript, it will get executed in once this eval will go in. So, AJAX and JS manipulation, JS script, JavaScript exploitation through XSS, identifying DOM points like document.write, eval, etc. And then there are various different attack APIs which can be used to compromise the network or try to exploit the browser. So for example, over here what I've done is I've created another Ruby script to scan some of the AJAX code. For example, we want to scan this guy over here. So I take this, copy this link, and I say scan AJAX. And this is the link which I want to scan. So now you can see it has scanned the link. In the first place, it has identified which libraries or which JS files are included in this particular page. In a second, what it has done is it has parsed the lib.js file and mentioned number one, get JSON profile is a function which is making XML HTTP request object, and then you can see it is making 3 document.write call. So now you can analyze these part of a code and determine that from where the stream is coming. So this will give you, there is no one-click solution for AJAX code because these are all code is written manually and by customized code. So there is no one-point solution where you can say whether it is vulnerable or not. What you have to do is you have to identify entry points and you have to analyze the entry points from where the streams are coming in. So this is the way you can dynamically use the scripts to identify entry points once you have a sound knowledge of what you're looking for. So this is all about JavaScript exploitation with XSS and such. Another area which is opening up is RSS. If you heard of, like, a lot of vulnerabilities were reported in RSS readers. Various different Google RSS reader, Yahoo RSS reader. We're running with a vulnerability where manipulated RSS script are capable of injecting code into a browser. Injecting script to RSS feeds and AJAX call may be executed. One click, malformed lava. Say for example, one click exploit is coming to you. As soon as you click the link, the JavaScript would get executed. It is leveraging on click, on mouse, etc. events. So over here, if we go to the example, demo, here is RSS demo, and here is a news.aspx page. So for example, here is a small widget or a small RSS reader you have where you have already configured what kind of a feeds you want. So you have a CNS business, USA Today, Business Today, etc. And what I have over here is disable Firebug and enable Firebug. Now what I'm doing over here is view page source, just to show you from where the feeds are coming. Over here you can see there are various different feeds are defined, and these feeds are actually coming from a third party URL. So what we are doing over here is we are calling proxy.aspx code and telling it to give me a news feed which is residing on rssnews.example.org. Now this feed is not trusted. So it can be, any end user would have defined several different streams which is coming from various different places. Now I call this stream trade news. So news, one line news has been loaded, and as you can see there is links. Now as soon as I click this link, XSS has been executed because this particular link was coming to me in a JavaScript form. The href was JavaScript colon whatever script I want to execute. So this is the way RSS readers were found vulnerable, and as you can see over here, the request through XHR has been made to RSS news example demos RSS news, and here is the vulnerable link. The link itself is injected, which is saying JavaScript alert. So as soon as this RSS feeds come into my browser, it will boom it. So next I want to show is, so you covered RSS. Okay. So this is all about RSS injections. Another interesting area which we are looking at, the cross-domain call, how to bypass same origin policy. Now, essentially what we have is like, when you are on a page would have a DOM, and DOM would have a document.domain. So if your document.domain is a.com, then you can't make certain requests to b.com, c.com or such through XHR. So XHR is following the same origin policy, where it can't make a call to different domain, or it can't make a port, it can't make a request to a different port on a same domain as well. So the developers have come up with different ways of bypassing this single sign-on policy, or what you say is a single origin policy. How they are doing is, either they are creating a proxy, which we have already shown. So they will make a call to a proxy, and a proxy will make a call to the end client. Or what they are doing is, they are implementing something called crossback or a callback. So what we are doing over here is, it will make a callback. It will send Yahoo or say Google, etc. are providing this callback mechanism. So what you have to do is, you have to call the URL, and in the URL you have to suggest the callback, that when the content come back to me, which function I am supposed to execute. So this is called a callback mechanism. So over here, for example, if you go for a cross domain, here what I have a cross domain with proxy. So as soon as I click a show profile, it will make a request through proxy.aspx and will send a URL. So my browser directly can't make a request to this particular URL. Since I am on a demos.com, it won't be able to make a request to a blog.example.org, but it can make a request to a proxy. Now I have received the entire JSON stream, and I have repainted the browser. Now over here, I have a different way of bypassing the same origin policy. Over here you have seen there is no XHR call, but when you do a view page source, here is what we are doing. We have a script where the SRC is shown, SRC blog.example demos xdom get profile, and I have defined a callback, profile callback. So whenever I get the stream back, this particular page is going to call a function, profile callback, and it will pass all information whichever has come from the server to it. And this is the way, through script or through iframe, you can make the cross-domain call. So it is like a bypass to cross-domain call. So this cross-domain issue can cause CSRF or other sort of vulnerabilities, where it is possible to do through a cross-domain call. Now let's quickly look at the one vulnerability. So what I'm doing over here is, assume that someone has already logged into bank, and now it is browsing through certain pages. One thing which we have already seen, that through CSRF, what you can do is, you can initiate unintended requests to the backend server. But these calls were usually a one-way call. You can make just the request, but whatever response has been fetched back, you can't read the response. But now, if this response is coming in a JS array, or it is coming in a JSON, and if it is not guarded well, then what you can do is, you get a read access to it as well. So we are now, at this point, we are on a demos.com. Now if you look at the view page source, not over here, look what is going to happen here. Disable Firebug, enable Firebug. As soon as I click this, I have, say for example, I am a Rob, and I have already logged into my bank, and now I am browsing, and I am clicking this particular link, which is some kind of an auction site. So welcome to our auction portal. We are on a demos.com, but look at the back end what have happened. Someone has gone to Rob's bank, got entire information for his profile, and send it to attacker box. So it has been sent through AJAX, through collect ASPX, his data account number, his Rob Smith, his email. And when you look at the source, here is a source, what it is doing. What it has done is, it has used a script command with SRC, so there is no same origin policy. It has called the bank, and as soon as it will make this call, this cookie is going to be replayed. Once these calls get executed, it is actually coming. If you go to this page and open in a browser, this particular call is a Web2.0 call where it is sending the JS array. So JavaScript array is coming to it. Now these JavaScript array can be read by setter in a Firefox. So what I'm doing is, as soon as I overloaded the function array here, so as soon as this array will come, these function will get executed. And in this function, I am just using XHR and sending the information to collect.espx. So this is the way you can overload. So if you are sending, if your application is using JSON or JS array or any other these JS objects which you can overload in a Firefox, it won't work with Hive, but it will work with the Firefox. Then you will get a read-write access. So it will, like, you can fetch this information and send it across to the attacker. So this is a new generation attack which we are seeing, where XSRF is not a one-way communication. XSRF is emerging as a two-way communication. So this is all about cross-domain call. Defending AJAX is no business logic information on client side. Do not trust third-party sources. Filter it out. No direct cross-domain call. Filtering browser-level information. Avoid client-side validation as such. No secret in AJAX calls, which we are seeing sometimes. Proper data structure selection. Avoid client-side scripting and such in HTML filtering. Now we'll quickly look at some of the web services based attacks, threats and countermeasures. Here is a complete web services stack, which we have a presentation layer where XML security stack has AWS security, discovery stack would have a UDDI, Cisco, etc. Access stack has WSDL and SOAP, and then you have a transport layer where HTTP and HTTPS is running. Here is how security would look like. End client, where web services client is sitting. You have in-transit data, you have a vendor control area, and you have a user controlled area. And these are the points where the code is residing. So we are more interested in a web services deployment shell and a web services code components. You can do a black box approach method, or you can take a white box approach method for entire analysis. Risk in transit, you have in-transit sniffing or spoofing risk, you have WS routing security concerns, you have replay attack concerns. On a web services engine side, you have buffer overflow, XML parsing attacks, spoiling schema, complex or recursive load, denial of services or large payload. On a web services deployment risk, you have fault code leaks, you can have permission and access issues, you can have poor policies, you have customized error leakage, authentication and certification issues. On a web services user code, essentially all traditional web application attacks are possible over a SOAP or a REST. So parameter tampering, WSDL probing, SQL, LDAP, XPath, OS injection, virus, brute force, session tampering, format string, etc. Some of the things which you have to do to assess web services is a web services footprinting. You have to identify where the web service is running in an application framework. We know many companies, what are the company's name, on that basis you can do a footprinting. Like we used to do a generic DNS footprinting where from IP address we used to find the virtual host, or from a company's name we try to find an entire network block assigned to it or entire range assigned to it or such. Do you have any whois for a web services? UDDI is one of the component which you can query. So if Microsoft.com is running with its own UDDI server, and if you have address to UDDI server, what you can do is you can query UDDI server. And on a business entity, business services or binding template, you can do that. Or what you can do is you can do a web services discovery using Google or using MSN, where you go out and try to look for WSDL in a file extension, ASMX, JWS. All these are extension to web services resources. So over here I have my own tool which I'm going to post. You can use a Google discovery. You can assign a Google key over here, and then you can go ahead and say domain or a pattern on which basis you want to do query WSDL files, or you want to identify WSDL file. Or you can do a UDDI scan. If you have an address to UDDI, you can put it over here and try to query UDDI server. You can do a technology identification on which technology this particular web service is running. For example, over here I have a simple example where web services is running. Here is my sample application where here is access point. So access point where the WSDL standards are, or access mechanism for WSDL is. So I have it over here. Now I go. So what you can do is you can see the extension. If it is, say for example, it is running with .asmx, you know it is running on .NET platform. If it is JWS, then it is a Java web services and such. So this is one of the way you can identify the technology. Or when you make an actual request, for example, I have made a head request over here, and you can see X powered by ASP.NET. But as soon as I make a request to .asmx, you can see it is, I got another header called XASP.NET version 1.1. So on these bases, you can identify or fingerprint what technology or what web technology for a web services it is running with. One of the most important thing which you can do is you can do a WSDL scanning. The entire WSDL file which you can scan. WSDL file is nothing but the interface definition language which you used to have in Corba. So from WSDL file I can identify which methods this particular web service is supporting. For each method, what is input, what is its output and such. So for example, here is some nodes, data types, message types, services, access point, operation. So for example, here is a service node where I can identify where this particular call is going to go. Or over here I have a port type where it is suggesting method name. So this particular web service is running intro, get product info, get rebates info and such. Or over here I have for each method what are the inputs and outputs which I can identify in these particular nodes. So over here for this particular method the input is nothing but the output is a string. So on the basis of this I can make a complete profile of my web services which I want to assess. So methods, intro, get product info, get rebates info, what are the inputs, what are the outputs and such. So this is the way you have complete map of your web services. So this particular tool, so at the end what you get is a web services code. You have three methods. These three methods are actually mapped into your WSDL, which now you can call over 80 and 443 since this web service is exposed. So in this tool, if I go to WS Scanner, there is something called vulnerability scan. You can define your WSDL over here, and I say get. So it will go out and fetch WSDL file. It will analyze WSDL file and it will give you a web services profile. Now you can go to WS proxy. You can start the listening on certain port, and now you can say these are the 4 methods which is running on these particular web services. So I take get product info. I invoke this method. So this is the actual SOAP envelope. The SOAP envelope which would look like this, in which we are interested in ID. ID is, you can compare this parameter is like a query string or a post buffer which you are sending. I want to send 1 and I send it across. So it is get processed and I got a response back which is 200 OK, and you can see there is a first product info which I got, finding Nemo and such. So then I can send 2, 3 and such, and you can audit this particular parameter. So you can audit this parameter. There are various different, so for example, if I want to inject something over here, then I can inject, say double quote I want to inject. I inject double quote, and you can see I got a 500 internal error, and it has cuff up some errors and a stack information as well. So this is the way you can, automated fashion, you can audit the tool with this tool. You can even audit it. So there is an audit feature over, there is a properties for this where you can define different properties or audit parameters. You can do data type, you can SQL injection, LDAP, meta character, XPath, attack string and such. You can even brute force the envelope with a username, password. If envelope is taking username and password, then you can supply this through a file and do it. You can do a buffer overflow test, and you can parse or analyze the response which you are getting. So this is the way you can pretty much do this. Now some of the attack vector is through SOAP you can do XML poisoning. XML nodes can be manipulated. There are 2 types of parser, AJAX and a DOM. So you can, for example, here is a simple node, then you can inject nested node which will fail this AJAX parser, or you can create a multiple same entry node in your XML document. So for example, 100 times I am putting a first name, so the entire block is going to be read in a memory before parsing starts. So then you can load the entire parser and do XML poisoning or do a DOS. You can do a different parameter tempering. When you do a parameter tempering, fault code, which is coming in a SOAP, is very interesting. So over here, for example, we have, as soon as we injected this double quote, we got a fault code. You can see fault, then it is a fault code, and there is a fault string. Now it is saying that cannot use empty object or a column name. So now I know that these particular places is possible to have SQL injection. So instead of 1, I go for 1 or 1 equal to 1 and send it, and we have SQL injection. So now instead of seeing one product, I am seeing all the products. So this is the way SQL injection is possible. Now you can do XP command shell, all different things which we already know in SQL injection. We can do with this over SOAP. Or if you go over here, say rebates info, I invoke this. Then here is a parameter which which can be tempered as well. So this is the way you can do a fault code parameter tampering. Over here I am passing the file name which doesn't exist, so it is coming up with a fault string which is saying a C:file not found. So now I know that this particular is a file, so I can download the file through it. So over here, if I go and I do file info, I send it, I got this particular error which is saying this file doesn't exist. So what I'm doing now is I'm doing // and I try to get .aspx file. So I send it, and you can see I got the entire source code of the file through SOAP envelope. So now I have identified various different way to get into application over a SOAP. So then you can do SQL injection, which we have covered. You can call as 1 or 1. You can do a column name. These are the few vulnerabilities which I discovered in a .NET framework which reported, and MSRC has already fixed from 2.0 version. Then you can go for 1 or 1. You can do this. Even you can do XP command shell executing on the server, and then you can read the executed command. You can do XPath injection, where you can, instead of SQL injection, you inject the XPath code. So various expression like // by which you can read the various different nodes. Here is like a vulnerable code where the red line where you are doing the SQL injection, and as soon as you put single quote or 1 equal to 1, what it's going to do is it is going to break the XPath query like a SQL query, and it will become a first node. So you will, before even not passing the username and password combination, you can become the first user of the XML document. You can do LDAP injection, LDAP authentication, various places. If there is a LDAP integration has been done over a SOAP, then you can do various different LDAP calls injected into your SOAP. File system access, which we have already covered, where you can do, when you identify a parameter where SOAP is making a file system call, you can use this. You can do a SOAP brute forcing, where username password combination in a SOAP envelope. It is not like a basic authentication. It is like a parameter which are residing in a SOAP envelope. You can do a brute forcing on it. You can do a parameter overflow, passing a large overflow into a parameter, and you can break the system. You can do operating system access code, access controls like a pipe or a semicolon. Or you can do even a session hijacking, because every web service is running with a session, individual session. If a web method is enabled with a session, then you can do a session hijacking as well. And there are a few other attack vectors like external referencing, XML schema, XSS attack, and such. So that is pretty much on our web services. There are various different ways. If you get my book, then there are few chapters written on complete theory behind how you can do a web services attacks. And then on a countermeasure side, you countermeasure through a secure coding or providing a web services based firewall or something like that. So this is all about web services. So pretty much covered industry on a larger point. We covered at AJAX, and then we wrapped up with XML based web services. So any questions? My email is this. I have a blog where I do post my new tools in development. Any questions at this point? I'm open to take. No questions. Okay, thank you very much for listening patiently.